last video, I have explained the general mechanism of electrophilic aromatic substitution. This class, I am going to teach you few examples of aromatic substitution, of which the first one I want to begin with nitration. So, nitration of benzene. Okay, so any aromatic compound also you can take, students. Here I am giving you the example taking benzene. So benzene on nitration gives nitrobenzene. How does this happen? When benzene is treated with nitration mixture or nitrating mixture, we get nitrobenzene. What is nitration mixture or nitrating mixture? It is nothing but concentrated nitric acid plus concentrated sulfuric acid is called as nitrating mixture. I have given you the reaction here. To start with, I have taken benzene plus HNO3 takes place in the presence of H2SO4 giving nitrobenzene plus H2O. So here in the place of hydrogen, NO2 group is being substituted, which we call it as nitrobenzene. So below I have just given you the nitration mixture, students. And if we look at the mechanism, so the last class we have seen that this electrophilic aromatic substitution involves 3 steps, of which the first step is how the electrophile is being generated. That's nothing but generation of electrophile. Okay, so in this reaction, how electrophile is being generated, I will show you. So taking the nitration mixture, HNO3 I am taking, students. HNO3 I am writing like this plus H2SO4, I am just showing it like this. Okay, so H2SO4 we have H plus, HSO4 minus. I have written separately so that you can easily understand. Fine. So here, students, generally oxygen will have 2 lone pair of electrons. Okay, so with 1 lone pair of electrons, it takes up H plus. Okay, so that means a bond will be formed between oxygen and hydrogen. So here comes H, O, H, NO2 plus what is remaining? HSO4 minus. Okay, now there is only 1 lone pair. This lone pair is involved in the bond formation. So only 1 lone pair. Now it is not having this lone pair because it is involved in the bond formation. Therefore, it gets a positive charge. It means oxygen atom. So how this positive charge is being satisfied? So the bond between oxygen and nitrogen. Oxygen takes up these 2 electrons and hence look here, students. Oxygen is getting back the 2 electrons with the 2 hydrogens. What is being formed? 2 hydrogens plus oxygen, H2O. Water is being formed and hence there is HSO4 minus and water. H2O plus H2O plus HSO4 minus plus what is remaining here? NO2. Now this bond, as it is attracted towards oxygen, this nitrogen, now it has positive charge. So NO2 plus, which is called as nitronium ion. Now this is the electrophile which is being generated from nitration mixture. Students, whichever class or whichever video or whichever textbook you watch, all these things will not be given. Okay, just they will give you HNO2 plus H2SO4 gives rise to NO2 plus HSO4 minus plus H2O. What exactly happens is this. First I am showing you. This is HNO3 plus H2SO4. H2SO4 I have written it as H plus and HSO4 minus. So oxygen with this lone pair attracts H plus. So H plus and oxygen with a lone pair. A bond is being formed here plus HSO4 minus. Now oxygen acquires a positive charge because one of its lone pair of electrons is involved in the bond formation. Now this positive charge is being satisfied how? It attracts or it draws the two electrons which are there in the bond between oxygen and nitrogen towards itself, so that H2O comes out plus HSO4 minus plus NO2 plus. Now nitrogen gets positive charge because now it has no electron, and hence this is called as nitronium ion, Nitronium, which is the electrophile. Now this electrophile will be involved in the second step. Students, before going into the second step, I want to clarify one thing here. I told you now, whichever video or whichever textbook you watch, all this will not be there. So I want to clarify it. So the nitration mixture HNO2 plus H2SO4, directly it will be shown H2O plus NO2 plus HSO4 minus. How this NO2 plus is being formed, I have shown here. This part is only for your information, only for your understanding sake. Okay, so you need not write this portion in your notebooks. Fine now, just start with HNO2, H2SO4, directly you can enter H2O plus NO2 plus HSO4 minus. Clear? Right. So students, second step is formation of the intermediate carbonium ion. Do you remember students? First step is the generation of electrophile. Now electrophile is nothing but the electron deficient species. So they move towards the electron rich species. I told you in the last class why these aromatic compounds act as electron rich species. Now as we started the reaction taking benzene, this NO2 plus, that is the nitronium ion, it approaches benzene. So second step I have written here benzene plus nitronium ion. I have written one hydrogen outside. When this electrophile approaches benzene, it undergoes electromeric effect. So what happens? What is this electromeric effect? I am showing here this pi bond, the two pi electrons, they will be shifted to one carbon, by which this carbon gets negative charge and this carbon gets positive charge. So generally NO2 is plus and this minus attracts this nitronium ion. Hence nitronium ion NO2 plus comes and gets attached at this carbon. Okay, so here next students I am writing the positive charge here. Here comes now NO2 group. Here is hydrogen. Okay, now this positive charge is not static. It's not restricted to this carbon. Now this pi electrons moves in between these two carbons. Now this positive charge will be shifted here. Here hydrogen, NO2 group. Next, this positive charge will not stay here. Why? Because these two pi electrons move this way. So here comes the positive charge, hydrogen, NO2 group. Okay. So now this is the carbonium ion, intermediate carbonium ion, which will be stabilized by the three resonating structures, and these three resonating structures are represented by the resonance hybrid, fine. So this dotted lines means the movement of the pi electrons inside the ring, and the positive charge is also concentrated on ortho and para positions, that we can show it by representing the positive charge in the center. Okay, so this is the second step, formation of intermediate carbonium ion. Next is the third step students, formation of the final product. Okay, So second step, taking the resonance hybrid, that is the intermediate carbonium ion plus HSO4 minus. Okay. So what happens now in the final step? This HSO4 minus, it abstracts the proton. See how I am representing the arrows, students. I am not touching the bond between carbon and hydrogen. Okay. That means H is going out as H plus. So now you tell me H plus HSO4 minus H2SO4. Now this what happens to these electrons? They will not stay in the air like that. Okay. It will be these two will be shifted towards the ring. Why? Because there is positive charge. Actually, there should be 3 pi bonds inside. But in the intermediate carbonium ion, there are only 2 pi bonds. Now, one pair of electrons, it will be shifted inside the ring, by which we get all the 3 pi bonds. Now, plus H2SO4. H2SO4, which acts as a catalyst. That is, the reaction is taking place in the presence of H2SO4. Okay, students. So this is how nitrobenzene is being formed on nitration of benzene. Hope I made this mechanism clear. Second example, students, Friedel-Crafts alkylation. Okay. So what is this Friedel-Crafts alkylation? Benzene on reaction with alkyl halides. So general representation of alkyl halides is RX. I have taken alkyl chloride, RCl, in the presence of anhydrous aluminium chloride, AlCl3, we get alkyl benzene. So here you can write, students, this is alkyl benzene. That means in the place of hydrogen, R is being substituted. Okay. Plus HCl. So as usual, this mechanism involves 3 steps. First one is generation of the electrophile. So what the electrophile is and how the electrophile is being generated, let us see in the first step. Okay. So taking alkyl chloride plus AlCl3, what happens? This Cl with the 2 electrons will be taken up by AlCl3. Already how many chlorine atoms are here? 3. So one more is coming. That means AlCl4 minus. Okay. Now this R is deficient in electrons. That means R plus is being formed. This is the electrophile, which we call it as alkyl carbonium ion. This alkyl carbonium ion is involved in the second step. Okay. That means this approaches benzene, and we will see how the second step takes place. Okay. Next, second step, students, formation of intermediate carbonium ion. So the electrophile which is being generated in the first step, how it involves in the second step. That means as it approaches benzene, okay, look here, I have written benzene ring plus the electrophile generated in the first step. So it undergoes electromeric effect. The same mechanism, these 2 electrons will be shifted to this carbon. So here this gets minus and this gets positive charge. So this minus carbon with a negative charge attracts the electrophile. So therefore next is the formation of intermediate carbonium ion. R comes and gets attached to this carbon. Here is positive charge and these are the pi bonds. Okay. It does not stay here, as I told you. These 2 pi electrons will be shifted this side. So positive charge. Now it comes to the para position. Next, here comes the positive charge. So these 3 are the resonating structures which can be represented by the resonance hybrid Okay. So there is no pi bond here, ma. 1 second. Fine. Here H, here R. This is the resonance hybrid. All these three resonating structures, we can show it in the form of one structure. So this is the carbonium ion, intermediate carbonium ion that is formed in the second step. Okay, clear students? Next, third step is formation of the final product. Taking the intermediate carbonium ion formed in the second step. Now, this when treated with AlCl4 minus, this chlorine with a negative charge abstracts the proton. So, H plus Cl minus, that is HCl plus AlCl3 comes out as it is the catalyst plus don't forget to shift these two electrons inside the ring. So this is what the alkyl benzene. Students, in this place of R, any alkyl group CH3, C2H5, C3H7, any group can be used here, right? R is the general representation of an alkyl or aryl groups also. C6H5 also can be substituted, can be written in the place of R. Okay students, so this is all about Friedel-Crafts alkylation. Understood now? Next example students, Friedel-Crafts acylation. Previous one is Friedel-Crafts alkylation, this one is Friedel-Crafts acylation. So there alkyl halides are involved, here acyl halides are involved. The general formula of acyl halide R C double bond O X, I have taken here acyl chloride. Okay, now the reaction benzene plus acyl chloride in the presence of same anhydrous AlCl3 gives acyl benzene or acetyl benzene plus HCl. Okay, so this is the reaction of Friedel-Crafts acylation. Now if you look into the mechanism, first step as usual, generation of the electrophile. So how the electrophile is being generated and what the electrophile is. So RCOCl acyl chloride plus AlCl3. So here what happens is this takes up this Cl minus. Okay. So what happens now? RC double bond O plus. Okay. This is the electrophile which is called as acylinium ion plus AlCl4 minus. Okay. Now this is the way how electrophile is being generated. Have you understood students? AlCl3 takes up Cl with the 2 electrons. So Cl with the 2 electrons is going out. Therefore AlCl4 minus. Now this carbon has only 3 bonds. So it gets the positive charge. So this is the electrophile. Now this will be involved in the second step. Okay students, second step is formation of intermediate carbonium ion. The electrophile which is generated in the first step, now it approaches benzene ring. Okay, so this RCO plus, this is the electrophile. When it approaches the benzene ring, this undergoes electromeric effect as usual. Here minus, here plus. Now this minus attracts the electrophile. So here comes the positive charge. Now, how will you attach the group here students? Will you write RCO plus? No. Here the positive charge is on carbon. So, carbon comes here, double bond O, R. If you write this side R and C double bond O, it will be wrong. Fine. Now, this positive charge will be shifted here. H, C double bond O, R. Here comes the positive charge. Next, these 2 pi electrons will be shifted this side. Here comes the positive charge. These three are the resonating structures represented by the resonance hybrid. H, C double bond O, R. Okay. Now, we will see how the final product is being formed in the third step. Next, third step is formation of the final product. Students, I think by this time you understood and you can do it on your own because all the three mechanisms, all the three examples which I have shown till now following the same procedure or the same mechanism. Okay, so here in the last step, the Cl minus abstracts the proton. Okay, so I am drawing the arrow like this and the two electrons will be shifted inside. Here comes C double bond O R. This is called as acyl benzene. Okay, plus AlCl3 plus HCl. Okay students, so this is the final product. Understood now? This is all about Friedel-Crafts acylation. So R, C double bond, you should not attach R here because R has no positive charge. This carbon has the positive charge. Fine ma? So this is all about the three mechanisms students: nitration, Friedel-Crafts alkylation and Friedel-Crafts acylation. Okay, so hope I made all these three mechanisms clear. So if you liked the explanation, if you like the mechanism, don't forget to like, share, and also if you have not yet subscribed till now, please subscribe. Introduce this channel to your friends. Don't be selfish. Let them also be benefited. Okay students, stay safe, stay home, take care. Bye-bye.